Hello, welcome to the class. Let's dive into the problem. The stored charge in the capacitor in steady state of the following circuit is dash microcoulombs. In the circuit, 12 volts of voltage is connected with all these resistors and 100 microfarads of capacitance of capacitor as well shown in the circuit. For this, let's decode to know the charge in the capacitor. Let's decode the circuit. 12 volts of the voltage of battery connected with all these resistors and capacitor as well shown in the circuit, and the flow of the current it from positive terminal to the negative terminal as shown in this circuit. Okay, in the question they have stated that it is a steady state of the DC current. When it is a steady state of DC current, capacitor will be fully charged and the resistance will be very high, so that the flow of the current right across 10 ohms will be 0. So this branch will be acted as an open circuit. For this, let us omit this 10 ohms of the resistor in this circuit. For this, and again, if you see the rightmost part of this circuit, 4 ohms, 4 ohms, 2 ohms, and 10 ohms. Let us take this loop and apply the Kirchhoff law. Okay, for this, the flow of the current will be like this, from this node to this node, and this node to this node, and here it flows like this. The flow of the current will be like this. If you closely observe, it is a 4 ohms, 4 ohms, 2 ohms. There will be a no junction, and the current is not dividing it any node of this loop. And here, if you observe, here is the flow of the current divides into two parts. This two, this way and this way. So it acts as a junction. At the junction, this resistor will be in a parallel with these three resistors. Okay, let us find out these three resistors total value. 4 ohms plus 4 ohms. They are in series connection, so that it is a 10 ohms. The rightmost part of these three resistors, total resistance will be 10 ohms, and with these three resistors, this 10 ohms of resistor will be in a parallel connection. So that let us find out the equivalent resistance of these four resistors. Equivalent resistance of these four resistors will be 10 into 10 by 10 ohm, 10 plus 10 ohms. This is equals to R equivalent resistance at this loop. That will be 5 ohms. The equivalent resistance of the rightmost loop of this part will be 5 ohms. This is 5 ohms. Equivalent resistance of these four resistors. And go for this loop. 5 ohms, 10 ohms, 2 ohms, and 12 ohms. Here we get that the equivalent resistance of all these four resistors will be 5 ohms. So I am taking 5 ohms here. Let us take 5 ohms and 2 ohms and 12 ohms. Okay. With these three, flow of the current again from this node to this node as well here. And same way as earlier loop, it is also the 12 ohms is parallel with all these three resistors. So let us find out the um, resistance of these three resistors. 5 ohms plus 5 ohms plus 2 ohms, 12 ohms. This 12 ohms, these three equivalent resistance of these three resistance will be parallel with the 12 ohms. So that 12 into 12 by 12 plus 12, equivalent resistance of total, equivalent resistance of the total circuit is equals to 12 into 12 by 24. You get 6 ohms. The equivalent resistance of a total circuit is 6 ohms. Now we get the equivalent resistance of the uh, total equivalent resistance of this all the circuit, and to know the flow of the current in this circuit, what is the formula? V is equals to IR. V is 12 volts. I should be find now, and the equivalent resistance of our total circuit is 6 ohms. So that current flow in the circuit will be a 2 amperes. The 2 amperes of current flow in this total circuit. Let us find out the total current, the current flow in these loops again. Okay, the 2 amperes of the current flows with the from the positive terminal to as well shown in the picture as earlier. Okay, the 2 amperes, the 2 amperes of the current flows and reaches its this node, and it divides into two parts, at this way and this way. Okay, it divides into 12. The total of this 3, 5, 5, 12 ohms of these three resistors will be 12 ohms, and these resistors which is parallel with all these three resistors will be also 12 ohms. So it divides into two equal parts. Two equal parts, that in the sense at it let us call it VA, village voltage drops at A point, voltage drops at B point, voltage drops at C point. Okay, let us, the flow of the current divides into two equal parts at this point, and this point will be 1 ampere. 1 ampere at VA, and 1 ampere at VB. Again this VB, again this VA, VB and VC. Again this VB divides into two equal parts. Okay, because it's a 10 ohms, all these three resistors, equivalent resistance will be 10 ohms. So it divided into equal parts at 10 ohms. It is a 0.5. At this part, 4 ohms, 4 ohms and 2 ohms, with which they are in series connection. That will be 0.5 amperes at VC. At VC position, VC node, it is a 0.5 amperes of current will be flow. Okay. Now This capacitor is parallel connection with this 4 amperes, 4 amperes of resistor. Okay. To know the charge that stored in the capacitor will be, to find that what is the formula, Q is equals to CV. Q is equals to C is given that 100 microfarads into V should be find now at this part 0.5 amperes. Okay, it is directly connected with the capacitor. The 4 ohms, at the 4 ohms, the flow of the current will flows to the capacitor directly, so that at V is equals to IR, as we know that at 4 ohms, at voltage of at 4 ohms, 0 point current flow of the current will be 0.5 amperes and resistance at 4 ohms. How much? V is equals to 2. The voltage drop at the V is equals to 2 volts. Let us substitute this 2 volts in this equation. Q is equal to 100 into 2. You get Q is equals to 200 microcoulombs. This will be the answer. Thank you. Thank you for watching.